welcome back, everybody. We are now moving on to geometry. So I'm trying to remember, we did congruence already, and again, I'm doing this alphabetically. So that was a lot of like graphs, right? Because it's technically geometry. So let's see what this one is doing with. So it looks like I got transformations, so we've done that already. Number 2, right triangle. And remember, my brain automatically, every time I think about right triangles, is a squared plus b squared equals c squared. Okay, good old Pythagorean. All right. And I got another triangle, reflected, some more transformations, Pythagorean theorem again, volume. Oh, okay, volume's a new one. All right. And then more transformation. Number 6 looks like we've done already if you did congruence. I see another right triangle right there. More transformations. Find the distance, which we kind of did if you did that other one, okay, with me. I'll show you when we get to it. Another right triangle. Okay, so a lot of Pythagorean, and it looks like we got some volume questions. Okay, so let's go ahead and get started. Now my mind's getting ready. All right, I kind of have an idea of what I need to focus on. And if you notice, calculators everywhere, okay? So let's see. Let's look at this figure. Okay, I got two boxes. They look the same. And I obviously got transformed somehow. So read the statement. So how did you get from that one to that one? Select true or false. All right. So rectangle sock, so that's the original, all right, was rotated 180 degrees clockwise about the origin. So here's the kicker. So if I rotated 180 degrees about the origin, I'm going to pick this as my point, and I got -4 and 3. So if I go this way, that -4 and 3 now switches to 3 and 4. Okay. So now it's 3 and 4. And then we switch it again. And we go to 4 and 3. So that is obviously wrong. That's false. Okay. That did not work out well. So that does not fit. What else could I have done? You translate the rectangle sock 10 units to the right, and then you reflect. So 10 units to the right. Okay, there's my W. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So there's my new W. And then you reflect it across the X. So if I reflected, I went 1, 2, 3 to the mirror, because there's my mirror, and I flipped over 1, 2, 3. Yeah, that worked out. Let me see. Then my A got flipped. Yep, that works. So this one is true. Okay, and then finally, you reflect across the X and then across the Y. So I'm going to reflect across the X. So there's my K and W. So if I go 3, I'm going to go 3. So right there and right there. And then my rectangle, let's draw this. So now this is my K, that's my W, my S, and my A. Prime. And then it said it got reflected across the Y. So if this is my mirror, I went 1, 2, 3, 4, and then 1, 2. Nope, that did not work. It does not get reflected. It actually got translated. So this one was false. All right, next one, look at the triangle below, enter the value of x, and like I said earlier, I got a squared plus b squared equals c squared. So a squared plus b squared equals c squared, 8 squared plus 15 squared equals x squared, and then calculator time, so let's bust that handy thing out. So what do I have here? I have 8 squared plus 15 squared, and that gives me 289 equals x squared. So how do I get x by itself? Well, the opposite of a square is a square root. If I do it to one side, I do it to the other. That square root and that square do not cancel. It gives me a power of 1, okay, because I have x to the 1 power, so the x by itself. So let's clear this on my calculator, put our square root, put 289, and I got 17 equals x. And does that answer make sense? Yes, because the hypotenuse should be the longest side. So in this case, 17, yeah, that makes sense. All right. So next one, let's see. Triangle muck is translated 4 units down, then reflected. So that means it is congruent. Okay, reflection and translation are rigid. That means it's the same triangle. Okay, it didn't get bigger or smaller. Remember, that's dilation. So nothing like that happens. That means it's exactly the same triangle. So let's see if that helps. Muck is similar and congruent to muck prime. That is true. Okay, right here, right? This means similar. The other one means congruent. But if you notice, the congruent sign also has a similar sign in it. Does that help you kind of remember? It can be both. Okay. So muck is similar, but not congruent. So if it's similar, no, okay, we just said it is similar and congruent. So that one is false. Side MK is longer than UK. Side UK and UK prime are the same. Yes, I know that for sure because I said it's the same triangle. The one that's weird are these two because I don't know how long those are. So let's see, will anything help me figure that out? Well, what if I graph these? So it would help me to graph them over here. So -4 and 3. Really, I made a mess of that, huh? Is there a nicer one? I guess I'm going to do it right here. So 1, 2, 3, 4. 1, 2, 3. Boom. There's that. Then -4 and 8. 1, 2, 3, 4, 5, 6, 7, 8. There's U. Oh, that makes it easier. Okay. And then K is 1 and 3. So technically here it is. So this is -4. This one is 3 all the way to 8. So let's look at what I have here. So MK is right there. I went from -4 to 1. So if I do that, that's 1, 2, 3, 4, 5. So MK is 5. What about UK? UK, I don't know what UK is. But if you think about it, this is a square. I mean, it's a right triangle, right? And I just said earlier that the hypotenuse is longer than the other two sides. So if that one is 5, then technically this one was 5 because I went from 3 to 8. So that means that UK is longer. So what is my question again? Side MK is longer than UK. That is false. Okay, it's the other way around. So notice I could, if I didn't make all this mess, technically I could have just, graphed this over here, right? A lot neater. I could have just erased all this stuff, right? I just left it because, you were working on it and I'm going to have my answer key on neat and stuff. Anyways, there you go. Moving on. Look at the right triangle below. That ain't no right triangle. That's a lie. Okay, can you see why? I can. Salvador shows he can use the Pythagorean theorem to solve for the value of x. Is he correct? Why or why not? So can you use the Pythagorean automatically? No. So why not? Because we don't know what kind of triangle? Okay, because Pythagorean can only be used on right triangles. That is not 90. Right? You need a square, right? 90 degrees, remember? Yeah, that's horrible. So it has to be like this, right? 90 degrees. Okay, number 5. Mr. Beltran has a cylindrical can of coconut milk he's going to use to cook curry. Yum. The can is 8 inches tall and has a diameter of 4 inches. Which is the closest volume in cubic inches of the can? Oh, yeah. So notice all these numbers are pretty spread out. So the trick with this one is, do you know the equation for a volume of a can? So if you remember, a circle the area is pi r squared. Now, if I kept stacking that circle and stacking and stacking and stacking, I would get a can because it's a cylinder. So if I stack these and stack and stack and stack and stack and stack and stack and stack, think about a bunch of quarters, right? If I stack a bunch of quarters, doesn't it look now like a cylinder? Okay. So that means I multiply times the height. That's it. So that's our formula. So what's our volume? Well, it says that I have to use pi. My radius has to do with diameter. The diameter is the whole thing. And for our radius is only half of the diameter. So r equals 2. Now what's the height? It is 8 inches tall, so times 8. And at this point, it is just calculator. So let's bring that back out. So volume equals, look, pi, perfect. Oh my God, they already gave me pi. Parentheses, r squared, so 2 squared. Close my parentheses, times 8. So I literally copy it just like it says, right? So all of this is calculator. Exactly how I wrote it. And what is my answer? They even give it to me 100.53. Perfect. So pretty simple. The thing that's going to be annoying for volume is remembering the formulas. All right, and I already looked at this. A lot of it has to do with your circle. Okay, so you have to know the volume of a cylinder, a cone, a sphere. And all of those have to do with circles. Okay. All right, moving on. Triangle LAT is transformed by reflecting across the x-axis or y-axis. So they moved it here. Followed by a reflection across the x-axis. Okay, not a big deal. So check the boxes that go with what sides are equal. Well, one thing I know for sure is that LT is S. So the tricky part is which ones are the other ones. So let's think about what's going to happen. So since that one got mirrored, if this one is on the left, if I mirror it, now, how do I mirror it? That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Boom. How long is it? 1, 2, 3, 4. So 1, 2, 3, 4. Actually, this should be in green. 1, 2, 3, 4. So here's the thing, right? This is on the left side, and now it is on the right side. So this one's on the right side. Now it got mirrored. It's on the left side. It's like when you take a selfie. Okay, it's a mirror. So it flips it. So when I go this way, then it's now the same one, which is a little weird, right? So this one right here is O, and the other one is I. So let's go back, and we've done this a lot in the congruence ones. Now my life should be a lot easier. So LA is red, so that is I. AT is purple, so that is O. And TL was green, so that was S. All right, so Mr. Bertrand is building a ramp for his grandpa's house because he's now on a wheelchair. Pobrecito. Yeah, I had to do this for him. Below is a sketch that he drew. Enter the length of the top in feet of the ramp when he finishes. So in other words, that X is also right here. So if you think about it, this is a squared plus b squared equals c squared. So a squared plus b squared equals c squared. 6 squared plus 17.5 squared equals c squared. Calculator time. So clear 6 squared plus 17.5 squared. And that equals 342.25 equals c squared. And what did we say earlier? How do you get rid of the square? You take the square root. Take the square root of both sides to be fair. That gives me only 1c. And if I take the square root of 342.25, I get 18.5 as the length of my ramp. So 18.5. All right. Number 8. Resistance below and verify that it is congruent, so it is exactly the same by selecting true or false. So CRO once translated 8 units to the left. Is that true? So CRO, that means that C is the same as B. This is why I love geometry, okay? Because they literally tell you the order and the corresponding angles and sides. So C goes with B. Then it says that R goes with A, which means that O goes with T. So that's where you got to be careful, all right? So let's see, is this true? Well, Crow was translating 8 units to the left to get bat. Well, that means that my C had to get to B. That is 1, 2, 3, 4. Yeah, no, that did not work. That is false. Okay. Crow is reflected across the y-axis to get bat. Well, there's my y-axis. Did that get flipped over? No, because it has to be smack dab in the middle. So that's your mirror, okay, which is x equals 2. So this one was false. So Crow was reflected across x equals 2. Yep, that is true. Okay. All right. 9, another a squared plus b squared equals c squared. A squared plus b squared equals c squared, but these guys made it a little different because that's my a, that's my b, and c is always across the 90 degrees, aka the hypotenuse. So let's see, 5.6 squared plus x squared equals 7.8 squared. So calculator time. Let's see, clear that. 5.6 squared is 31.36 plus x squared equals 7.8 squared, which is 60.84. So how do I get the x by itself? Well, first I have to get rid of the 31.36, so I'm going to subtract 31.36. If I do it to one side, I'll do it to the other. So now that gives me 0. So I'm left with the x squared by itself. And I got 60.84 minus 31.36. And I got 29.48. So again, how do I get rid of the square? I take the square root, That gives me 1x. And I take the square root of 29.48. And I get 5.4295487, blah, 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 blah. Now, why do I write all of them? Because I don't know what they want me to do. I got a long decimal, and they said round to the nearest hundredth. So going back to elementary school, probably. Remember when your teacher used to spit at you, right? I hope they don't now. But it was always that lesson. You got to do the 10th, 100th, 1000th. Yeah, remember that? It's a little traumatizing for me, if I'm being honest, because I used to sit at the front, guys. It was pretty gross. But, I mean, at least I remember, I guess. Anyways, so round to the nearest hundredth. So that's my 10th, that's my 100th. So you got to look at the third number. So because that one is 5 or greater, that means that the 42 has to switch to 43. So now it is 5.43. All right, number 10. Look at the graph below. Enter the distance units between point A and point B. Round to the nearest 10. So I'm going to be getting a decimal again. And you're like, what is happening? Well, think about it. We kind of did this in a different quiz. And the trick to this is like, well, what do I do? So think about it. You are trying to find the distance from here to there. So how do you do that? Well, Forgot which quiz it was that we did. Okay, because it wasn't a vertical or horizontal line, if you remember. Okay, it was a diagonal. Okay, so diagonal lines are annoying, but any line that's diagonal on a graph, we can make into a right triangle because we just go straight down. Let me use this one. I go straight down and then across, and I technically just made a 90-degree angle. So now I can say a squared plus b squared equals c squared. So let's figure out what a and b are. 1, 2, and I can't count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I do this correctly, I'm going to have a squared plus b squared equals c squared. 9 squared plus 10 squared equals c squared. Nine squared plus 10 squared is 181 equals c squared. Take the square root, take the square root, so I get c by itself. And then I take the square root of 181, not 11, 181, and I get roughly 13.45362. Again, that's just my habit. Because then I look at my tenths place. So if it's the 10th, that's 1 decimal place. So if I look at the next number, it's 5 or bigger. That means this one's got to go to a 5. So 13.5. All right, triangle APT. Oh, it's a Bruno Mars song, huh? Anyways, is blah, 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 is reflected across the X, followed by a rotation. Enter the measurement of angle TPA prime in degrees. That's weird. Okay, this is like high school stuff now. So I'm like, why would they give you this type of question? So I'm like, they should have made it easier for you. Again, this is because I've done so much math in life. Okay, so like angle. So that means angle TP, not B, TPA. So if you read it out loud like that, can you see that the little symbol I drew for an angle, right? It's literally right here. That's what an angle looks like, right? It's that. So the way you got to think about it is why I said geometry is kind of nice because you just got to learn how to read it correctly. Well, it says I started at T, right? Because I went in the same direction. Then I went to P, and then I went to A. So there's angle TPA right there. Okay. So how does that look like in the graph? Well, I don't have it, but I can use the graph up here, hopefully. So let's try to graph it, shall we? So let's look at this. I have A, which is 4 and 8. There's 4 and 8. There's A. P is negative 3 and 8. And then T is 4, 4. So there is my triangle. So here's the kicker. Remember, we did this with the congruence quiz. If it got reflected and if it got rotated, it's exactly the same triangle. Okay? It's just now it is prime. Okay? Prime. That's what it means. So if I'm looking at my angle, I care about P. So where's P at? P is right there. Ew, that one's gross. You know what? It should have said, yeah, this is high school. Yeah, I'm not doing this. Okay? What I should have said was angle A. So T A P. I take it back, guys. I take it back. So TAP. So if I do TAP, And that means this one is on here, and guess what? A is 90 degrees. Okay, so that one should have been easy. So here's, like I said, this is me, right? I make up my own problems and hope they work out. Usually they do. But every now and then I get something like this to get you guys a little flustered. So I apologize, but I want to make it a teachable moment here. So think about what I'm saying, right? Like, yeah, finding angle P, like, I don't know what that is. Angle T right here, I'm like, dude, I don't know what that is. But I know that this is a perfect square, right? So that's 90 degrees. So most likely they should give you something like that. The only other one I can think about, guys, just a hint, because I don't know. If they give you something like this, and this is 10, and this is 10, and it's a right triangle, and they're asking you for that one. So this is where it's weird. You're like, well, I don't know. Well, think about it. You should know that all your triangles are 180 degrees on the inside. So if these are both 10, the sides, that means that this one and this one should be the same because it's an isosceles triangle. Yeah, vocab here, okay? So if one of it's 90, you subtract 90, you get 90. So if you divide by 2, each one has to be 45 degrees. And this is for those of you who are a little bit more advanced. So you can kind of understand where I'm going with this because that's another question they might raise up, okay? To kind of challenge you a little bit. All right. When you get to high school, then you'll learn the 30, 60, 90, 45, 45, 90, and all those. But this one, I think you can handle if you understand, right? Oh, they're both equal, right? Because they're an isosceles, and one of them is already 90, so they have to be the same. Okay, moving on. Enter the distance between points -1 and 3 and 5 and -7 and round to the nearest tenth. So here's the kicker. You can do the distance formula, where you can have x2 minus x1 squared plus y2 minus y1 squared. But if your teacher showed you, the distance formula is literally just a squared plus b squared equaling c squared. Wait, what the heck? But why is there a square root? Because how do you get rid of the square? I took the square root and I took the square root. So do you see how I get the c by itself, aka distance? So that's what we're going to use, okay? I'm going to just draw it on a coordinate plane. And I'm going to use one of those that works. So -1, -3, I guess I'm going to use this one up here. So -1, -3, -1, -3, boom, right there. Then I have 5, -7. So there's 5, -7 right there. So my job is to find the distance for here, okay? And this is number 12. So what do I do with this? I just got to make it into a right triangle. There's my right triangle. A squared plus b squared equals c squared. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So now I can go back down here and say a squared plus b squared equals c squared. 4 squared plus 6 squared equals c squared. And then I get calculator time. 4 squared plus 6 squared. That equals 52. Then I take the square root. So I get c by itself. And the square root of 52 is roughly 7.211102, blah, blah, blah. What do I round to the nearest tenth? So that's one decimal place. So because my next number is less than 5, I leave it at 7.2. All right, last two. Whew. A science lab uses various glass containers to store liquid chemicals. The containers come in different shapes and sizes. Determine all containers from the list below that hold the same volume of liquid. So they have to be the same. So which 2 or 3? Oh my God. Really? These guys gave me every single different thing I told you about earlier. Okay. So a cone So here's a cone, right? So if it's a sphere, a cylinder, pi r squared h. If it is a cone, three cones fit into the same cylinder if it has the same height and same radius. So the volume is 1/3 pi r squared h. And if it's a sphere, that's a ball. So a ball is 4/3 pi r cubed. So those are your formulas. Your job is to figure out which ones are the same. So let's start with the cone. So the volume equals 1/3 pi r squared h. 1/3 pi. My r is 6. My h is 4. So calculator time. And here's what I'm going to do. Because every single one of these has pi, I'm just going to multiply everything else except the pi. Okay. So I got 1/3 times 6 squared times 4. That gives me 48 pi. So notice I left that alone. Because if I multiply times pi, do you see how it gives me an annoying number? Like I don't want to write a decimal. I'm going to leave it as pi. Okay? And you'll see why in a little bit. All right, next one. A cubical tank. So if it's a cube, it's length times width times height. But they're all the same. It's a cube. So my volume is length times width times height. Any rectangular prism. But because it's a cube, that makes it special. 6 times 6 times 6. So 6 times 6 times 6. That equals 216. All right, next one. A sphere. So volume equals 4/3 pi r cubed. Or 4/3 pi. And my r is 5 cubed. So again, multiply only everything except the pi. So I have a fraction, 4/3 times 5 to the power of 3. Yeah. So that gives me 166.6666, or just put 67 pi's. And then finally, a cylinder. So volume equals pi r squared h, or pi, my r is 4, I square it, my h is 10. So I get 4 squared times 10, and that gives me 160 pi. Okay, so which one of these matches? None of them. Oh my god, that's annoying. But you don't understand, guys, how hard it is to come up with these, okay? Like off the top of my head. So in this case, it didn't work, okay? On versions 1 and 2, some of these should match, okay? So I'm going to have to fix this later for myself just to have a correct question, even though I'm technically already done with the video, but whatever. I'll just do what I got to do later. So, yeah, it's the same amount of work. It's the same equations. But again, you're going to just have to focus, right? That versus that versus that and that. So 2 of those should have matched at least, okay? Because again, if it says 4 boxes, you're going to pick 2 or 3. So on your test or quiz, 2 or 3 of those should match for sure, okay? I already know because I'm looking at the second version that I wrote at my answer key. Hint, hint. If you're watching this video, you're paying attention. 2 of those matched for number 13 on the quiz, okay? For version 2. Hint, hint. All right, number 14. Moving on, okay, because I'm over it. A cone with a diameter of 10 feet and a height of 15 feet is shown below. Enter the volume of the cone and nearest hundredth. Okay, so volume equals 1/3 pi r squared h. 1/3 pi, my r is not 10. That's my diameter. And r is from the center to the edge, which means it is half the diameter. So that's 5. I'm going to square it, and that's 15. Put everything in the calculator. So fraction 1/3 times pi times 5 squared times 15, and it's stressing me out because I can't see the whole thing. So does that look exactly the same? 1/3, yes. Pi, yes. 5 squared, yes. 15, yes. So my grand total is 392.6990817. What do I care about? The nearest hundredth. So my nearest hundredth is 2 decimal places. So because that one is bigger than 5, I got to round up to the next number. And this one is going to give me from 69 to 70. So 392.70. All right, and that was it. I am done with geometry. So until next time.